This recording will be looking at Chapter 8, and we'll be looking at geometry today. And specifically, we're going to look at angle measurement. Our objectives are going to measure angles, but we're not going to use a protractor. That's something that you probably have done in the past because this is an online course. We'll be talking about measured angles, but we won't be using a protractor. We will be talking about angle classifications and using simple geometric relationships involving intersecting lines and triangles. And that's going to be really the most important part as we build up to the next section. So when we're looking at angles, we want to really be able to talk about and understand how we're going to describe them. So we can describe the angles here as either P, which is right here, O, R, which is one way to describe them, or we can go the other direction and we can talk about angle ROP, and so it goes both directions. It doesn't matter. Notice that O is in the middle though, because it's the angle that's in the point that's in the middle of the angle. And so when we look at the interiors of angles, when we talk about the classification of interiors, we can see that the interior of this angle is called A, and the interior of this angle is called 1. They're different angles, and we could have called them anything. We could have called them Fred or George or anything, but A or 1, using variables with letters and numbers are the most common. So when we're looking at angle facts, it's really important that we're going to understand what happens when lines intersect and some of the things that you can see with the angles that are similar to each other. So in this case, looking at angles A and C, notice that both of those angles are 30 degrees. And they're also right across from each other, A and C. You can also see that angles B and angle D, and notice the way that they're labeled with a little angle sign in front of it and D, are also opposite from each other, and they are also equal. So opposite angles are equal. Adjacent angles, when we're looking at adjacent, meaning angles next to each other, just like if somebody lives adjacent to you, are important because when we look at those, we can see that they are 180 degrees. And so just to make sure to remind everyone that if we have a circle that goes 360 degrees around and we bisect that circle across, that is 180 degrees, half of 360 from here to here. And so when we see that here, we can say, okay, well, let's just draw a line here. Well, then we know that P and Q, which are adjacent angles, are going to equal 180 degrees. Likewise, if we look at angles Q and R, and let me get my eraser here to be able to get this off. If we look at angles Q and R, we can see that those also are 180 degrees. So those are adjacent angles. So looking at this and then bringing in triangles, we know that triangle is a polygon with 3 sides, and each place where the polygon meets, they're the vertices. And one of the really things that's important to know and to remember is that the angles in a triangle, no matter how big the triangle is, no matter how small, how flat, how wide it is, that it always comes up and it equals 180 degrees inside the triangle. And so when we look at the degrees inside, so we look at angle A, it says it's 69 degrees. Angle B is 36 degrees, and angle C is 75 degrees. And when we add all those up, we see that it adds up to 180 degrees inside the triangle. Now, if you have a couple parallel lines, then you're going to need to remember exactly what a parallel line is, and that is basically, I think of it like this, as a train track. Train tracks never cross, at least unless they're going to change tracks, but that doesn't count. We're talking about simple train tracks, and they're always parallel. They always go with each other. If one of the train tracks veered just a little bit towards the other one or away from the other one, then the train couldn't stay on the tracks, and so they're exactly parallel with each other. Now, if you do bring in, and so these are going to be our parallel lines that we're talking about here. Now, if you do bring in another line, and it crosses a set of parallel lines, remember that lines have to be parallel, and this is called a transversal. And inside a transversal, there are very important angles that are formed and named. And so, if we look at angles from parallel lines that are inside, and they're called alternate interior angles of the transversal, then in between where the parallel lines are, then you can see that those angles are going to be the same. And so the angles, the alternate interior angles for C and F are going to be the same angle. Likewise, for D and E, that's going to be the same angle. So when we look at that, we can extrapolate later on that the angle that is angle C is going to be the same as the angle that is angle F. Likewise, if we look at corresponding angles, then what we can say is that those are also going to be the same angle. So angle, in this case, angle B and angle F are going to be the same angle as each other, and likewise with D and H. And so that's going to be really important as well as we look at and we calculate when we try to find the missing angle measures, knowing certain things. And so remember, if we have a set of parallel lines, if it has a transversal, then we can understand the alternate interior angles and the corresponding angles to be able to find missing angles that we might not know. And this is applicable in real-world scenarios. So let's go ahead and look at this real-world scenario where a plumber is connecting two vertical sections of pipe, and you'll notice that the pipe has a 30-degree elbow here. And so it's saying, okay, well, if angle X up here, angle X is a, or it's looking for the angle for X. And so it says to help solve the problem, we extend the horizontal and vertical lines as shown in figure 2. So what they're saying is extending the horizontal line and the vertical line. Now, when we do that, we come up with a right angle in right angle B. And so because we know that angle B is a right angle, and we know that that it has listed that angle A is a 30-degree elbow up here, then we can say, okay, if we know B down here is 90, A is 30, so, and we know that a triangle is 180 total, then we can say that 180 degrees minus our 90-degree angle minus our 30-degree angle means that C, right up here, is going to be a 60-degree angle. And with that information, we can go ahead and look at trying to solve for X, because we know that X up here, remember this is what we're looking for, this is the original question, that X is going to be the difference between angle C down here as the alternate interior angle, and we're going to be able to say that if it is 60 degrees, and we know that 180 degrees is a straight line here, and that angle C of this is going to be 60 degrees of it, then that the adjacent angle X is the remainder of it, and it is 120 degrees. Likewise, we can look at the same problem a little bit differently, and so it's the same problem, but there's more than one way to skin the cat. And so in this case, we can look and see, and this actually uses that information that I pointed out last time about alternate interior angle, and it's still the same problem where we look at the pipe with the 30-degree angle. We're still looking for X right here. But this time we say, okay, rather than extending the vertical and horizontal lines, let's draw a couple parallel lines. Ooh, that was really a bad parallel line. Let me see if I can get that a little straighter. Okay. So we're going to extend this line. Not much better. Sorry about that. Not truly. We're going to extend those lines. And then we also know that if we extend those lines and we then follow this, that we have a transversal. If we have a transversal, then we can go ahead and find out that we have what the angles are, because we know that A is a 30-degree angle here. And so if A is a 30-degree angle and we're looking for X, which is this angle up here, so the total angle of this, so which is going to be the total angle, and let me draw that in blue, a total angle of this, and we can say, okay, if we know that X is 30 degrees, then we can also say that D is 30 degrees, so right here, because of the alternate angle, and then if that's 30 degrees and this is 90 degrees right here, then we can say 30 degrees and 90 degrees is 120 degrees. So basically you break the problem up in a couple different ways. Geometry is nice like that. It's a puzzle and depends on how you want to put it together. Just remember the rules, the basic rules, and you will be able to solve the problems.